My name is Kevin. I've been a mechanical engineer here at Saratech for about 1 year now, and in that time I've supported numerous design projects with the use of Simcenter 3D as my analysis tool and NX CAD as my design tool, as well as supported on the customer software support side as well for Simcenter 3D and NX. So today we're just going to be giving a general overview of the post-processing side of Simcenter 3D. So the simulation has already been completed and now you're just working with your results. You're getting it to show certain results, generating certain views, and maybe manipulating or choosing specific data to display or graph. And I'll also show how you can save your post view templates. So without anything further, we're just gonna hop over to our pre-post application on NX here, which is Simcenter 3D. And so now, as you can see here, I have a completed simulation for a jet engine fan blade. And this is just one segment of the fan blade. As you can see, if I return to the original model, we have 40+ fan blades in a complete assembly here. But we were actually able to utilize the fact that this fan blade was axisymmetric so that we can only isolate one section and make our lives a whole lot easier by just applying our boundary conditions and constraints to that one section. And later on, we can leverage the fact that it was axisymmetric to propagate the results around the entire blade. So to get over to our results, we just navigate on the resource bar here from our simulation navigator down one to our post-processing navigator. And you can see as part of the product of this solution, I've produced a structural result as well as a thermal. And we're going to look at the structural, and to do that, I'll just double click to load them in. And I have 3 outputs here. I have a modal analysis that's analyzing the part at rest. I also have another modal analysis with the same modes, but it's doing it 1,000 seconds into the simulation. And I also just have a straight up loading case here. And that's the first thing we're going to look at here is our loads. And so to view any of your results, one thing you could do is you could double click them. And if you have a lot of results, for example, my modal analysis here actually, if I open one of these, say harmonic index 1, you can see I have 20 modes here, and that's for each harmonic index, and each mode has its own suite of results that I've programmed to output. So first thing, if you want to just get a general overview of how your results came out, you can come to one here. For example, I'm going to start at displacement, and you can use this tool on the results tab called next mode or iteration. And every time you click that, it simply goes to the next result. So you can see now mode 2 is highlighted, and that's because it is now showing the displacement on mode 2. So if you have a lot of results like I do here, and you just really quickly want to get a quick look at all of them, you can just cycle through your modes and iterations with these arrow keys here. And you can see it's just going down my modes, and it's showing just the displacement for each of them because that's what I selected. If I was to select, say, this rotation and go through, it would be showing the rotation for each of them. So that's just a sort of helpful little tip if you have many results and you want to view them very quickly at the start. So I'm just going to return to my model, and going back to my loading case, I'm just going to view my displacement here by double clicking on it. And notice you automatically get some color coding that correlates to a legend here. The legend lists the types of results that you have displayed. We are displaying displacement, and you can see there is a deformation of the part that is also displayed. If I quickly return to the model, you can see that's the original shape. And if we go to our displaced model, that's an exaggerated look at how the part has deformed. So your result will also output that for you. So let's say now that we're at our results, the simulation is done. You need to prepare certain results for either an internal presentation for your own company or for a customer. So that could entail changing the display and also pointing out certain types of data. So we're going to start with some display settings. And most of that you can do right here in your edit post view. If you open that, you can see we have options to control the result type, the display, the deformation, and the legend. So just starting with our result, right now I have displacement open, but I want to change the result type to my von Mises stresses. So I could do the same thing that I did before, just double click on the tree here, or I can go to my result tab and just change my result type to von Mises stress, elemental nodal, and hit apply. And notice the part updates and the legend updates as well. Also the information for what kind of result you're looking at on the top left of the screen here updates as well. So that's one way you can change your result type. Notice the color transition on the part is smooth. And this is because the data I've selected is nodal based. And so as such, it's being transitioned across each element. If I was to select an elemental view, it would just show one value per element, and thus showing just one color per element. And it would be a lot, bulkier, less smooth. But if that's your intended purpose, you could do that as well. So speaking of the colors, you can actually go over to display here. And if you want, you can uncheck that. So if I go ahead and do that, you can see now we're in grayscale, which that could be useful for printed reports if you need. But for us, we do want color display. I want to show that legend. But let's say I want to go to a banded display. So right now I'm on smooth. If I click banded and hit apply, you can see that change there. The banded display basically shows one color for a range of values defined by the color bar. And so for us, yeah, let's say in our purpose, we do want to keep the banded display. So that's good. But maybe we want to make the legend a little more detailed. So these colors, the separation of data isn't as bulky. So to do that, we can go ahead and come to our legend tab. And there's a whole host of tools to edit your legend here on the graphics window. And so let's say I want to first adjust the min max, the legend extreme. So I can change that from just displayed to specified. And now I can kind of make that a more detailed range. I want this to start lower, so at 1, and end higher, so at 2000. So if I hit apply, you can see that automatically adjusts the legend. And it's still a little broad for me. I want to make this detailed, so you can also adjust the amount of levels. So right now there's 12. I want to go to 20. If I hit apply there, you can see that adjusted. And now, even though I had selected a banded display for my colors, because my legend is so detailed, it actually outputs a pretty detailed color display as well. So if I was to go back to my display here and change that to smooth, it's not that different, but I want banded. Okay, now last, let's say I want to decide whether or not we want deformation. This tab here controls the settings of the deformation shown in your model. And right now it's set to the scale of the deformation is exaggerated to 10% greater of what was experienced in reality. So if I was to up that to 50%, it would be a lot more exaggerated. As you can see, that's a little crazy. So right now, 10% is good for me. You could also adjust that as an absolute value, a ratio. So right now it's 1. If I was to change that to 5, you can see it gets a little more exaggerated there. But I do want some deformation just for presentation purposes, but not too much, just enough to show the the displacement of the part. So one way you could visually see that is if I click OK here, you can animate your result. If I just go up to the animation section here and press play, you can see it shows our deformation of the part as a result of the analysis. And you can adjust that result by clicking on the animate command, and you get the dialog box. And you can choose whether you want to include your color or the deformation itself. So for example, if I was to deselect deformation, you would just be getting the color propagation there. And if I was to select just deformation but leave color, you can see the color result stays, and now I'm just getting the deformation. And you can also adjust your style if you want linear or modal, as well as the number of frames. For example, if I was to change that to, so let's say 20 frames from 8, it should be a lot smoother of a motion, which you can see it is. So now you can also, if you want, for presentation purposes, you can export your animation as a GIF file. So that's pretty helpful as well. And last thing, let's say we may want to do here for display purposes is open multiple view windows at once. So to do that, you can see where my mouse is at the top left. I'm at a single view layout. I can go ahead and say I want to compare a side by side of two different results. I can do that. And then I simply come over to my tree here and let's click displacement. And I'll say new plot. And I right click that, by the way, new plot. And I just select the window I want to place it in. So now I've got two side by side results, which can come in handy for comparing two different types of results. You can even animate them both at the same time if you want. So that can come in handy as well. And let's add even more views. Let's say we want 4. So right now I have a displacement and a stress. I want to add some thermal strain. I'll add that, and some temperature loading as well. Right click new plot and select that window. Now, when you have multiple views open like this, it could be hard to control the display of each of them individually. So one thing you could do is say synchronize all views. And once I hit that, you can see all views are synchronized. Or you can get a little bit more specific and just say this synchronize views command, and then you just click the ones you want. So I want these 3. I hit the check, and now you can see the 3 views that I selected are synchronized. So to continue, we're just going to return back to our original view. And now before I move forward with this single fan blade, recall I mentioned that this was an axisymmetric part. It was symmetric about a center axis because we had that whole fan blade assembly. So after I'm done with this, let's say I want to move on in my workflow to preparing a report that shows multiple blades. So I could do that by going to this edit post view and saying results, set symmetric results. And now you can see I can leverage the symmetry and access any of those as many of those fan blades as I want. So if I go to selected, let's say I want the first 17 blades. Say OK. Wow, you can see Simcenter gives that to me, and when I did this analysis, I only applied my boundary conditions and constraints to one blade. It just used the cyclic symmetry to understand that this is a symmetrical part, and it could apply my boundary conditions to all of the blades. Now I'm going to continue with my single fan blade, but if I want to save this, I can go down here to my post view, right click, and let's first name it. So I'm going to name it multiple blade results. Okay, and I'm going to say add new template. So later on, I'm going to show you how we can come back and access that template that I saved. So for now, we are going to return to our primary display here. And I've adjusted the view how I want it. I got the colors to be the banded display I want. The legend is how I want. So now maybe we can move over to selecting our data that we want to present. So let me go ahead and return to the model here. Let's bring our displacement result up. Now, there's a lot of displacement going on in the tip of the fan blade here. So let's say that's something I want to examine. So I could go over to my results tools here and say identify results. And actually even better, something that probably be even more critical, if I go to stresses here and I want to examine these shearing loads here at the base of the fan blade, I can simply go to this identify results tool and start clicking relevant values here of high stress that I want to look at. And note that the stress values are being displayed on the selected items in the graphics window, and also the data is being shown in the dialog box in real time. And now I'm going to move on, but let's say this selection particularly was a little difficult for my part. It took a lot of time. I don't want to clear this selection and have to reselect it at a later time. So what I could do is, once it's all selected, I could say save selection in group. So if I do that and I close this dialog box, if I actually come up back here to my simulation navigator and go to my groups, you can see that post group there has been saved. So now if I return to identify results, instead of picking from my model, I can say elements in group. And this is the only group I've created on this part so far. So it's automatically populated in the selection box here. So I have my post group 1. If I hit apply, you can see that all that data has been saved. My selection has been saved, and it's showing it once again for me without having to reselect it all. So that's pretty nice. That's a pretty nice feature to have. Now, if I clear this once more, instead of selecting or going by elements in group, you could also bring up some results by element ID. So if you have a particular element ID in mind, which I do, this particular element here is in an area of high stress. So I can just type it in, and Simcenter already knows where it is. It selected it for me. It selected all the nodes surrounding that element. And so I don't have to do any manual selection process myself, which is pretty nice. Something you can do also, if you want to create a field out of your data, there's a command for that down here as well. So if I hit create field, and I'm going to accept these defaults currently for my field, and I close this, if I go to my simulation navigator, there's a drop down for fields. And you can see, in addition to my suction and pressure table-based fields that I used to run the analysis, I now have my element nodal stresses field. And you can open that up. And you can see it's automatically compiled the result from that element into a table-based field. Now, another thing you can do with your results is you can probe for certain results. So right here in my manipulation category of the ribbon bar, you can see I have a command for result variables and result probe. So let's say I want to probe for a certain stress result. I can actually create a variable for that. I'm going to call it example stress 1, and the result type, again, is going to be stress, and the location, I want it to be element nodal, and I want the component to be von Mises. Now, we're going to keep it simple, so I'm going to accept the rest of the defaults and create that variable. And you can see now that variable is created. Now I can probe for certain results via a formula, and in that formula, I can use any variable that I've created. So I'm just going to bring in my example stress formula here. Now, you can create a variable and for stress and construct, let's say, a factor of safety formula. So by doing that, it will display any results that are, let's say, violating a particular factor of safety. So this result probe is a pretty powerful tool. And so I'll just hit OK there. And because my variable was simply the von Mises stresses, it's just displaying the von Mises stress result. But again, with this result probe tool, I could incorporate any variable that I create into a formula to probe for very specific result types, which is pretty powerful. So now that I've isolated certain results that I want, maybe I also want to create some graphs. And so I'm going to be looking at displacement for this, and I simply bring up my result, and I come up here to my tools, and I say create graph. And right now, we just have our manual selection tool going on. So our x-axis is here. Actually, let's go. Let's select here. Will be our load cases, and you can see our y-axis. We pick nodes manually off the model. Let's see. All right, so this is a pretty relevant spot when looking at displacement, the top of the fan blade. So I've selected a few nodes from the top of the fan blade. And let's go. Single. So let's go. There we go. On path. All right. I was wondering why that wasn't coming up. Okay, so again, I've selected some nodes from the top of this fan blade where there's going to be a lot of displacement. And if I click OK, you can see it prompts us to create that graph. And there we go. There are the magnitudes of the displacement along the length of the path that I selected. Now, we can do that again. We can, instead of clicking the command for graph up here, I can come down to my post view, right click and say new graph. And let's say it's kind of tedious to select all the nodes that I want across this top edge. So when I'm selecting, instead of setting my pick to single, I can say feature edge. And now you can see that's pretty nice. With one click, I can just select all the nodes across that relevant feature edge that I want. And again, if I hit OK, we get a nice plot that's displaying the magnitudes of displacement across the length of that path that I selected. So let's say now, so this was one set of data. Let's say you want to compare two plots across multiple iterations. So a good application for this would be to compare two of my modes from my cold modes against my modes at 1,000 seconds in. So let's create a graph, and instead of on path, we're going to say across iterations. And now my starting load case, let's say by iteration ID, my starting load case is going to be cold modes. So that's my modal analysis at rest. I want mode 3, and I want to compare it to my modes at 1,000 seconds. So my modal analysis 1,000 seconds into the fan blade moving. So I'm going to compare the same mode from rest to in motion. And again, we're going to select what nodes we want for that. And I'm going to go single. Let's say I want to compare a data point at the base of the fan blade to the tip and compare the magnitudes of displacement between those points across 2 iterations. So if I hit OK, you can see that plot is outputted, and you can clearly see the red plot is the displacement of the bottom node, and the blue plot is the displacement of the top node. It's experiencing a lot more displacement than the bottom node, and so it's showing that for you across the iterations that I laid out. So that's a pretty helpful tool. Now, say I've completed everything I want to complete post-processing wise for the single fan blade, and now I want to move on to my multiple fan blade result. Recall that I saved a template. So if I go over here to the left to the post-processing template navigator, you can see I have my multiple blade result saved and ready to go. And all I do is double click that, and that result comes up with whatever settings I applied and saved. And this tool is actually very helpful, especially if you have standard processes within your work and you do all your results a certain way. It's very helpful to create and save a template and just come back to it here in your post templates. So that's very nice to have. All right, so that being said, let's jump back over. So that was just, again, a general overview of the user interface of your Simcenter 3D post-processing tool. And some notable takeaways from that is really for display purposes, that edit post view command, where you can change your result type, the display, the deformation, you can adjust your legend, and you can also, very important, you can save a template of whatever result display you create. Also, the data selection and manipulation, you can see there's pretty fine-tuned data selection tools, and there's data probing tools. You can create a variable to probe for certain results. You can graph data if you like, if you want to kind of visually express certain things like displacement. And again, any type of result you construct, you can save it in a post view template, which is one of my most used tools on this application, because oftentimes I'll have to repeat my setup for displaying certain results.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.